I'm not a scientist, but I have a feeling that when atoms are energized, that is how they behave under the microscope.
Welcome to Solution Prime TV, and I'm a channel about more insight, whether a science, another science, whether go school, another go school. This channel no when you science. You see, science is nature, and we can't go away from nature. Yes, you are also part of the nature. So there are things in nature or the yes. In the mama can want something a gravitational force. Force to be a funny gravitational force. Sometimes full confuse gravitational force with force of gravity. Gravitational force is different from force of gravity. They are not the same. They are not the same. Let me give you example of gravitational force. Example, there's a gravitational force at work. Yes. Say when you sit down for a long period of time, you will see your buttocks. You feel pain. That is gravitational force. Another one is that when an object is thrown vertically upwards, with time you see that the object will fall back to the ground, and that is the gravitational force. The gravitational force I'm talking about is a natural force in space, and the gravitational force exists over every planet and every body be away into space. Sun has its own gravitational force. Earth has its own gravitational force. Moon, the same thing. Jupiter, Mars, stars, meteors, and other everybody's like meteors and other stuff. They all have their gravitational force. Obiani they are different. The reason why they have different gravitational forces is that gravitational force no the force na can gravitational force natural force no it depends on mass adene kese. So me for earth me the compare sun no much larger than that of the earth. So this means that the object no oye kese the bigger the object no the bigger the gravitational force. Object no ye kese no ne gravity so ye kese. Nti the reason why the planet still now won't move away from the sun is that the sun's gravitational force keep pulling the planet into itself. Yes, internet still now the earth and the other planet they don't move away from the sun. That is the gravitational force. And to that mama an example that I gave, when you throw objects upwards, the earth gravitational force will pull the object back into body be a space be a gravitational force. And the gravitational force no on a make the natural force and is the overall force. Let's go to the force of gravity. The force of gravity no exists on that particular planet. We know that all the planets revolve around the sun. Planet bia yenimdo oko sun around. Inti oko sun around no. Let me use Earth for example. When the Earth is rotating around the sun, there is a force or try to pull the objects out of the Earth. Inti wide or swing off. Yes, that is the force, and the force is the centrifugal force, or your force are all try to only pull objects away from the Earth, and that's the centrifugal force. The more force once the aging Earth no do not Earth no rotating, there's a force will pull out of the Earth. Now you have gravitational force now make also pull to the center of the Earth. So these are the two forces. Forces will only pin out of the Earth. Now forces so only pin to the Earth. And the gravitational force now you can want some that one is bigger than the centrifugal force. The more force now or try to pull out of the Earth now. If you want to know the force of gravity, you have to subtract the centrifugal force from the gravitational force. More back on your force of gravity. So force of gravity is a part of gravitational force. Answerable force of gravity no. Unless you subtract centrifugal force from the gravitational force, maybe your force of gravity. Into the force of gravity no on varies or sesa. Ebe earth no that or 9.8, sometimes 9.8 using it for calculation. Sometimes they will ask you to approximate you to 10. Sometimes they will ask you to approximate you to 10. Do you get it? Approximate you to 10. But when you go to the moon, it's different. When you go to the other planets too, the force of gravity is different because the rotation of the Earth, the rotation of the planet around the sun is different. Jupiter move faster. So you will see that there will be a change. There will be a change. So this is the difference between gravitational force and the force of gravity. Okay, so welcome to Solution Prime TV, and this one is going to be calculation aspect. If you are interested, you can continue watching. And we know is going to use the same concept of gravitational force, but in a different angle, because we are going to use that idea to solve problems, to generate. You are going to generate formula for gravitational force, and we are going to use the formula to solve problems. Yes. Okay. And that gravitational force, the law of universal force, no, it was proposed by Isaac Newton. So, you share my Isaac Newton. Okay. That is Newton's law of gravitation. Also, any two objects in the universe attract one another. That is what Newton saw. And so who the objects be our universe, they attract each other. So if I compare Earth and the moon and the Earth attract each other. Until we all pulling, the other side is also pulling. Earth is pulling moon, and moon is also pulling the Earth. That is what Isaac Newton was saying. The second one, the force becomes less when the objects become more distant from each other. Yes, more production there. If the distance between the two bodies in space is very far, then the force also become less, and it's true. If there's a bond between me and you, between two people, the far the distance, the lower the bond. Yes, so that is it. So it is clear. John Newton Ohui. Then the third one, the magnet. The third one, the magnitude of the force depends on the magnitude of their masses. Yeah, magnitude. We know that magnitude is talking about magnitude is a scalar quantity, only direction. Yes. So if a force, they are telling you that the magnitude of the force is the same as their masses. But in a vector wise, force is a vector, mass is a scalar. Yes, mass is a scalar. So you talk about the vector, the magnitude part of the force, because if you are considering force is a vector, and a vector is a quantity which has both magnitude and direction. But mass will be scalar because it has only magnitude. So if you are comparing the magnitude side of the force with this, also with the same thing, this means that the force is directly proportional to the mass. If the force increases, the mass will also increases. The magnitude of the force depends on the magnitude of their masses. Until when the force increases, the mass will also increases. They have the same magnitude, and it is proportional to their masses. And see, the Newtons came out with a law which is now known as the Newton's law of the universal gravitation. Yes, so that is the idea of Newton or the bear. So the my idea na there's a force will hold two planets or two objects in space. Yes, two objects in space. So Yanka Newton's law of the universal gravitation. Also, he says any two particles of matter in the universe attract one another, while a force which is proportional to the product of their masses and inversely proportional to the square and inversely proportional to the square of the distance between the centers. I think there's a mistake here. Let me confirm. Okay. So that is that. So Newton's law of the universal gravitation. Any two particles of matter in the universe attract one another, while a force which is proportional to the product of their masses and inversely proportional to the square of the distance between the centers of the two masses or objects, and that the force of attraction acts along the line joining the centers of the masses. What it's trying to say is that the Newton's law of universal gravitation, it talks about two objects in space, two particles, whether any two particles in space or only two particles in the universe. I can pick Earth and the moon or anybody in space, two bodies in space. So you pick the two bodies in space. It is saying that there's a force between these two bodies which attract each other, and that force is directly proportional to the masses of the bodies. So what it's trying to say is that these two bodies, there's a force that attracts each other. This force, this mass of the object is pulling this object, and the force of this mass is also pulling the force of mass 2. And that force is talking about is directly proportional, or is proportional to the masses of the individual bodies. Body A, let's say body A, body B, or body 1, body 2, their masses, the forces that is proportional to the masses, the product of the masses, and inversely proportional to the square of their distance, between them. That is the Newton's law of the universal gravity. So we are going to prove this based on the formula, based on the law. So let's move on. Newton is saying that the force F is proportional to the product of their masses. Is proportional to the product. You are going to use the proportionality sign in terms of math. Proportionality sign M1, M2. So it's proportional to their masses and inversely proportional to their distance, and the distance is the r. So what the law is saying that if two bodies in space, or two particles in space, attract each other, so they are attracting each other, this is attracting that, and this is also attracting that. So that is the force, and the force is directly or proportional to the what, to their masses. That is that. And inversely means, yes, to their distance, which is going to be 1 over r. So joining the distance and the masses together, we are going to get F is proportional to M1, M2, and inversely proportional to r. So until we know F is proportional to M1, the product of M1. So they are multiplying product of M1, M2 over their distance squared. I didn't bring the square, so I have to introduce squared. So that is what the Newton's law of the universal gravitation is saying. So if you want to introduce equal to sign, you have to remove proportionality sign. So if I remove the proportionality sign, equal to sign will come. That proportionality sign will be, that is the constant. If proportionality sign is off, we are going to introduce constant all over r squared. So that is the formula. And this F is the gravitational force. So gravitational force in the previous video, is the force of attract object, or force or attract object. So earth object be another local. These are the force or pull object backwards. So this force is attracting this, applying the same gravitational force. Also, this one is also pulling this object. So that is, so the force between these bodies is the gravitational force, which is the F. And the G is called the universal gravitational constant. Yes. Constant, which is simply known as the gravitational constant. Sometimes you call it gravitational constant. And the unit, it is a constant. So the value is G. Let me write it down. G is equal to 6.67 times 10 raised to the power negative 11 Newton meter squared, kilogram per kilogram squared. So that is the unit. So 6.67 times 10 raised to the power negative 11 Newton meter squared per kilogram squared. So that is the gravitational constant. So when they ask you to calculate for the gravitational force, they will give you mass of this body, the mass of the other body, M1 and M2, and they'll give you the radius. So when they give you the M1, mass of M1, the mass of M2, and the radius, you just substitute in the values and you calculate for your gravitational force that these two bodies exert on each other. So that is that. We'll try and solve one question and we are done. Okay, assuming question. Find the gravitational force if the masses of the two bodies in the universe M1 M2 with a distance of 10,000 meters. So this one we are going to get F is equal to G M1 M2 all over R squared. So our gravitational constant is 6.67 times 10 raised to the power negative 11 times the masses times 500 times 10,000 all divided by 1000 meters all squared. So you just punch this on the calculator, then you get your answer. After getting your answer, we know the unit for force. Force is measured in Newton. Then you indicate your unit. So that is the gravitational force. But for the force of gravity, that one is also constant. Is G. That is the force of gravity G, which is mostly 9.8 or so meter per second, or sometimes G is equal to 10 meter per second. So that is that.